This video is on another integration technique called integration by partial fractions. Specifically, we are going to look at non-repeated non-repeating linear terms. And basically, this is the only type of partial fraction that is on the AP test, so it's the only type that I'm going to teach you. Linear terms. So, back in the old days, you learned how to do stuff like this. 1 divided by x minus 2 plus negative 1 over x plus 3, and you were able to create a new fraction by essentially finding a common denominator. And so the way that I did this is you have x plus 3, and then you have a minus 1 parentheses x minus 2 on top, and then the bottom is going to be the two denominators multiplied by each other. You'll have the x minus 2 on the bottom times x plus 3, and then you can simplify everything. So the top will simplify to be like, what, 5? Yeah, because the x's cancel and negative minus 2 is plus 2, so 3 plus 2 is 5. And the bottom you can expand out to be like x squared plus x minus 6. Okay. In integration by partial fractions, what we're going to do is we're going to take this and go backwards to get the original two fractions. Here's why. Let's say that we want to integrate 1 over x squared minus 1 dx. Notice that we cannot do a u substitution, because if u was x squared minus 1, then du would be 2x dx, and we don't have that x, so we can't do a u sub. This kind of matches arctan, but it really doesn't, because remember, arctan was 1 over x squared plus 1, so we can't do arctangent here. So there must be another way. And the way that we're going to do this integral is using what's called integration by partial fractions. Here's what we do. I'm going to get rid of the integral for a second and just focus on the fractional part. We say, all right, we have this fraction, it's x squared minus 1. Notice that the bottom factors. It factors into x plus 1 times x minus 1. This is the key to this problem. You cannot do integration by partial fractions if you cannot factor. And basically what we want to say is well, this is going to be equal to some number a divided by this denominator x plus 1 plus some other number b divided by the denominator x minus 1. And we need to figure out what the a and the b are. And there's a really easy way to do it, as long as you have non-repeating linear factors, which is what we have, and which is why we're only going to learn this method, because it's really easy. The method is known as the cover-up method. This is what you do when it's very cold in Chicago or Minnesota. You got to cover up because it's cold. Haha, that was a joke. Okay, get over it. Anyway, so what we do is we say, all right, we're going to find, our first goal is to find a. Here's a. To find a, we are going to cover up. The first thing we do is we pick a value of x. The value of x that we pick is whatever x value makes the denominator 0. In that case, that would be negative 1. Then we trundle on over here to the original fraction and cover up the bottom part of the fraction that we were looking at. Since we were looking at x plus 1, we cover up x plus 1. Next, we plug in the value of x that we chose. And so we plug in negative 1, and so we get 1 divided by negative 1 minus 1, which is like negative 2, and so a is very simple, it's negative 1/2. That was a terrible 1/2, let me try again. Yep, negative 1/2, like that. Hey, guess what? For b, you're going to do the exact same thing. Let me rewrite the original fraction so we have it. So for b, you're going to say, all right, the x value we're going to pick is positive 1, because that's what makes the bottom 0. We're going to come over, trundle over here to our original fraction, cover up the x minus 1, and plug in x equals 1. We get 1 divided by 1 plus 1, which is positive 1/2, therefore b is positive 1/2. Great. Let me rewrite this so it's actually like legible. What we just did was started with the fraction 1 over x plus 1 times x minus 1. We decomposed this fraction into being negative 1/2 divided by x plus 1 plus positive 1/2 divided by x minus 1. And now we can go back to the original problem. The original problem was simply, well, what's the integral of all this stuff? And so now, because we were able to decompose the original fraction into two separate fractions, notice that, instead of an x squared on the bottom, we just have x to the first on the bottom. We have a linear thing on x. And if you remember stuff from an earlier chapter, these are going to be natural log integrals because you have a linear term on the bottom. That way you can do u substitution and the du will be equal to dx, and so you don't have to worry about finding the x on top. So the first integral will become negative 1/2 ln absolute value of x plus 1. Notice I did a u sub, but I didn't write it out because there's no doctoring or counterbalancing, plus positive 1/2 natural log absolute value of x minus 1. Don't forget your plus c. And then oftentimes you will see this answer completely rewritten using properties of logs. So notice that subtraction, the minus, becomes division. And so we're going to have natural log. The x minus 1 will be divided by the x plus 1 because that's the subtraction is here. So it's like this minus this. So therefore the x plus 1 is on the bottom. And then remember that if you have a constant in front of a natural log, it can go up to be a root, and so that would be the square root of all this stuff. So the answer would be natural log square root x minus 1 over x plus 1 plus c, and that would be your answer. Ta-da! And notice again that calculus is weird because we started with a somewhat simple rational function, and we end up with a crazy natural log and square roots and fractions and all this stuff. But calculus is kind of cool because now we can use partial fraction decomposition in order to do these integrals. Let's take a look at one more example, and this one will have a variable on the top. So let's see what we can do with that. So let's say we have 5 minus x divided by 2x squared plus x minus 1 dx. The first thing you want to do is check for u sub. Can we do u sub? No. Great. Move on. All right. So we have 5 minus x. The second thing we want to check for is, can we factor the bottom? And in this case, we can. The bottom will factor to be 2x minus 1 times x plus 1. You can check that, but I believe that is correct. And now what we're going to do is we're going to split this up using our partial fractions. So we have 5 minus x divided by 2x minus 1 times x plus 1 equals something a divided by 2x minus 1 plus something b divided by x plus 1. Alright, and now all we're going to do is use the cover-up method. So for this one, we're going to plug in x equals positive 1/2. So I'm not going to cross things out, but what I encourage you to do is like put your thumb or something over that term in the bottom so you remember to cover it up. So cover it up, great. Plug in 1/2, you're going to get 5 minus 1/2 divided by 1/2 plus 1. So we got a little bit of fractions to deal with. 5 minus 1/2 is 9/2, and 1/2 plus 1 is 3/2. 9/2 divided by 3/2 is 3, and so therefore a is simply 3. That's nice. Then for b, we do the same thing. X plus 1, the x value that we're going to use is negative 1. Come over here, cover it up with your thumb. Okay, that's me covering it up. Now I'm going to uncover it, but yeah. So you do 5 minus negative 1 divided by 2 times negative 1 minus 1. And so that's going to be 6 divided by, I believe, what, negative 3. And so that's going to give us a b value of negative 2. Very nice. Alright, this was our partial fraction decomp, but now we have to go back to the original problem, which was simply, what's the integral of all this stuff? And so now, most of the time, almost 99% of the time, when you do partial fraction decomp with non-repeating linear factors, you're going to use natural log. Alright, so with this first one, notice that we do have to actually think about the u sub. And so if we do the u equals 2x minus 1, then the du will be 2 dx. So we do have to doctor with a 2 and counterbalance with a 1/2 on this first one. So our answer for the first one will be, let's see, we'll have the 3 and the 1/2 left over. So we'll have 3/2 ln absolute value 2x minus 1. And then the second one doesn't need that doctoring counterbalancing term, and so it'll just be negative 2 ln absolute value of x plus 1 plus c. And then if we wanted to completely rewrite this, we could, using the subtraction and the exponents. We would have ln, the 2x minus 1 would be on top, and that would be to the 3/2 power. And then the x plus 1 would be on the bottom, and that would be to the squared power, because again, you would pull these exponents, or these coefficients up front as exponents, plus c, and that would be your answer. So basically what you're going to do for non-repeated linear factors is look for the cover-up method and then go for it. Pretty straightforward. Hopefully you understand it. Yay!